Hello, everyone. I appreciate you taking the time to be here today. We are going to explore one of the most essential components of the internet, TCP IP. This is the protocol suite that allows devices all over the world to communicate and share information seamlessly. Without it, the internet as we know, it would not exist. By the end of this session, you will have a solid understanding of what TCP IP is, how it works, why it's so important, and how it is used in our daily life. So let's start with the basics. TCP IP stands for Transmission Control Protocol and Internet Protocol. It's a suite of communication protocols that dictate how data is sent from one computer to another over the internet. You can think of IP as the addressing system on the internet. Every device, whether it's a smartphone, a laptop, or a server, has a unique IP address. And this address ensures that data is delivered to the correct destination. Just like a street address guides mail to your home. TCP, or Transmission Control Protocol, it's responsible for ensuring that the data you send or receive arrives safely and in correct order. It breaks large pieces of data, such as emails or web pages, into smaller packets, transmits them, and then reassembles them once they arrive at the destination. TCP also checks for any lost packets and requests them to be reset. Together, TCP and IP form the backbone of internet communication, ensuring that data travels from one place to another reliably. To really understand how TCP IP works, we need to look at its 4 layers, each with a specific function. First is the application layer. Now, this is where your interaction with the internet begins. It involves that you're already familiar with, HTTP. When you type a web address into your browser, you are using HTTP, which is the protocol for websites. SMTP is a protocol used for sending emails. FTP is used when you download files from the internet. Each of these applications relies on TCP IP to function behind the scenes, ensuring that the data is correctly prepared for transmission. Second is the transport layer, which is the TCP layer, and this is where TCP steps in. At this layer, TCP takes the data from the application layer, breaks into small manageable packets, adds sequencing information to ensure the packets arrive in the correct order at the destination. TCP also includes error checking. If a packet is lost or corrupted during the transmission, TCP will request the sender to transmit that packet, retransmit that packet, ensuring nothing is missing when the data is reassembled. Third is the internet layer or the IP layer. Here, IP protocol governs the layer, and each packet is labeled with the IP address of both the sender and the receiver. Routers, which act like traffic managers, use these IP addresses to direct packets across networks and ensure they arrive at the right place. Routing is one of the most important functions of this layer, as it determines whether the path that packets will take across the global network is the right one. Fourth is the network access layer. This is the layer where the actual physical transformation of data takes place. It involves the hardware, which is the cables, routers, switches, and wireless networks that carry your data from one device to another. This layer makes sure packets are sent across the physical network infrastructure, whether that's through fiber optic cables or Wi-Fi signals. So these four layers work together to ensure that your data can move smoothly and reliably from your device to its destination, regardless of the size or complexity of the network. Now let's take a moment to understand why TCP/IP is crucial for modern communication. Reliability. TCP ensures that data is transmitted reliably. It checks to make sure all the packets arrive at their destination, reorders them if necessary, and requests retransmission if something is missing. Interoperability. TCP/IP is the universal standard. Whether you're using a smartphone in one country or a laptop in another, TCP/IP allows different devices and networks and operating systems to communicate seamlessly. And this is why it's the foundation of global communication. Scalability. The protocol suite was designed to grow with the internet. It started when the internet was much smaller, but it has scaled to accommodate billions of devices and vast amounts of data traffic today. Efficiency. TCP/IP manages network congestion and ensures that even in cases of high traffic, data gets through as efficiently as possible. By breaking data into smaller packets, it allows for faster transmission and recovery from errors or delays. Now let's bring TCP/IP into focus with some real-world examples of how you interact with it daily. Web browsing. Whenever you visit a website, your browser uses HTTP, which operates on top of TCP/IP. Your browser sends a request, and TCP/IP ensures the data is sent in small packets to the server. The server then responds by sending packets of data, which your browser reassembles to display on the web page. Email. When you send an email, protocols like SMTP and IMAP rely on TCP to break the message into small packets and ensure they are delivered. Without TCP/IP, your emails wouldn't reliably arrive at the intended recipient's inbox. File transfers and downloads. Whether you're downloading an app, a document, or streaming video, the TCP/IP handles the reliable transmission of large amounts of data. FTP, or File Transfer Protocol, uses TCP to ensure the file is sent or received intact, with error checking mechanisms to recover from any issues during the download. In summary, TCP/IP is the invisible framework that allows us to communicate over the internet. Its layered structure, combining the reliability of TCP and the routing power of IP, ensures that data moves smoothly between billions of devices around the world. Thanks to TCP/IP, we can enjoy a seamless digital experience, whether we are browsing websites, sending emails, or streaming videos. I hope this overview has given you a better understanding of the crucial role TCP/IP plays in the digital world. Thank you for listening to me. Until next time.